so welcome back. I hope so. Now we are live. Actually, there was an issue. I was not able to come live properly. I hope so that I am visible. Well, I hope so. The stream key was not set up properly, but hello guys. Hello sir. Am I not live? I cannot see my feed. Guys, can you hear me? Hello. Oh yeah, we are live. Perfect. So we are a little bit late, but let us continue, guys. I was taking a class and suddenly the thing is that my camera was not set up properly and my stream key of my OBS was not set up properly, so because of that I got a little bit late, but apologies for that. Let us continue our class, guys. And what we were doing binary search tree. Yes. Hello Vivek, hello Ronnie Plays, hello VR ASD. Welcome back to the channel Kodazakit, guys. Welcome back. So let us continue our class for today. This is the 20th session of DSA placement series, and today we are gonna continue our binary search tree, finish up the binary search tree, and we'll try to finish up today only. Let us see how much we can cover in one class. Apart from that, we will try to do a lot of things here today related to binary search tree. Probably I'll be able to finish it today only. Let us see what all things we can do up, of course. Now guys, before I start with this live stream, I would like to request you people to please like, share and subscribe to our channel Kodazakit, and don't forget to press the bell icon so that you won't miss any future updates, and also to share this live stream as much as possible so that those people who want to learn DSA and they want to learn it for free also can learn it from this playlist. This is Ashank David. Let us start the class and let us continue from where we left in the last class. So what we have done in the last class, let me open up the, sorry, this is not the whiteboard which we are looking for. Let us create a new whiteboard. Okay, let us create a new whiteboard. Hello Ronnie Plays, hello VR ASD, hello Vivek, welcome back guys, and thanks for joining me in the live session. Let us go back and let us understand about the today's concept for which we are here. Okay, there we go. Let us start. So we were doing BST, which is binary search tree. Binary search tree. In binary search tree, we have understood that we can create a class called as node, and we can create a separate class called as BST, which can do the job of creating a binary search tree in a whole lot meaningful way. We have understood that how easy it becomes when you try to use a binary search tree class. So according to the skeleton of the program that we have still wrote till now, what we see here is that there is a node class here. In the public section of the node class, we have created the int key, node left, node right, as usual, as however we have created, right. Then in the constructor, we have written the constructor and we have passed the key, assigned the key, and then left to null and right to null. If those people who are not familiar with what is this, go watch my previous sessions, and if you are not Vivek, sir, I am watching your 4th session of this playlist. I will catch this soon. Yeah, Vivek, thank you so much. Let's continue. So if you are not getting this, then go watch my previous sessions of how I have done creating the class. Also, for those people who are not able to understand the constructor, this is what it's a constructor, right? So those people who have not known about the constructors, there is a dedicated playlist on C++. So go ahead, master your C++ object oriented, where I have taken the class for 5.5 hours class. It is going to be there. I have explained each and every concept of object oriented programming which is required for your DSA terms. I hope so that this is very much clear to all of you, correct? Alright, let us continue. So now we created a separate class called as class BST, and in this BST class we have two sections, as I was explaining in the previous session. Let us make a copy of it, and okay guys, my camera, just give me 1 minute. Apologies for this, but this will keep on happening because I am alone and I am the only camera operator with the teacher here. So yeah, so let us see, copy it into a new window, and let us keep this window right here, okay, and we have two windows here, okay. So on the right hand side, no, it is not working properly though, wait, I'll split this up, split left, correct, okay, much better. So here on this right hand side, on the left hand side you have the private section of the class, and on the right hand side I am doing the public section of the class. Where is the public section? The public section is right over here. Yeah, this is the public section. Now in the public section of the class we have BST, where we have initialize the root is equals to null, okay, and what we have done is void insert till now, where we were giving the key, and in the root we were updating the value from the insert recursively function, where we were passing the root value and the key value. Root was null, key was let's say 100. So what was happening, that the key was getting compared with the root value, and accordingly it was done. So this was the call, as I have told you again and again, and I keep on telling you again and again. I'll mark up the code and I'll explain this to you, that here the key value is, let's say, imagine 100, and the root value is right now imagine null. So initially the null value and the key value will be there, and you want to insert this key at the null. Of course there is no tree, imagine there is no tree, okay. So in that case it goes directly into the insert rec function. Now I need to scroll down a little bit. Say for example here, now you see guys, that what I will be doing here is, say for example the key is 100, let's do it again, and the root is null. So according to that root was null pointer. First it will go here, the key value is what, 100, this is what, 100, and the root value is null. It will go inside this and it will check if the root value is null. Yes, the root value is null, and when the root value is null, at the root which is null right now, allocate some memory and then insert the key. I hope so that this is very much clear to all of you, right? So in this case, new node, we allocate the memory and then we insert the key. So what happens is, at the root a new value is taken and the root is updated from null to 100. This is how your first insertion happens, and when the first insertion is done, then the actual another insertions in the left child and the right child keeps on happening. Okay, how does it happens? Let's say now the new value of root is 100. Now in this case the new value of root is gonna be starting from 100. Okay, so now let us say you want to insert 150, and if I want to insert 150, what I will do is, the key value becomes 150. So the key value becomes 150 and the new root value becomes 100. Now what happens is, if the root is null, root is not null, right, in this case, so this will not be executed, but the control will directly go here. Key value is 150, root value is 100. So 100 is, if 150 is lesser than 100, no, so this will not be done. Else if 100, if that is 150 is lesser than greater than the key which is 100 in this case, if that is the case, then go on to its right hand side, and then what do? you insert that 150 onto the right hand side. So, this is what we have done in the previous class, and this is the quick revision of that for this class, guys. I hope so that you have understood this really well. So, today what we are gonna do is we are gonna move one notch up by doing the next function in this case, which is search function. Search function is gonna be taught today in today's class, will be covered in today's class. So, search function. Now, why this search function is available? On the left hand side, you will have your search function helper function, search helper function basically. Okay, this is your search helper function. I hope so that this concept, this font size is okay, guys. If you have any problem with the font size, please do let me know. I hope so that this is very much clear. Okay, if you have any problem with the font size, please do let me know. Okay, now on the left hand side you have the search recursively function, and on the right hand side you have the search function. So, basically what we are doing here is, let us mark up the code and let us understand about how it works. So, guys, now you see right here we have the search function. This is what we are trying to execute now. Okay, what is the value of k? Let us say you want to search for 100. Let us say you want to search for 100 the root itself. So, search will call search recursively and it will pass the current root value, which is 100, and the key, which is 100. Imagine you have a binary tree like this, which has 100, here you have 50, and here you have a 150 like this, and you want to search for this element itself, 100. So, in this case the key value is 100, which needs to be searched. Root value is currently 100 and the key value is 100. You got my point, guys? I hope so that this is very much clear to all of you. Now, in this case, we want to search basically for the same root itself. Now, the call came right here, over here, okay, in this function. We are executing this whole function now. Okay, we are executing this whole function now. Okay, guys, now you see. Now you see, what was the value of root? 100. This is the starting index, right? 100. What is the value of key? What we want to search for? 100. Is root null? No, root is not null. If the root was null, then we would have returned false, that the key is not found. Okay, the value is not found. But the 100 is not there, 100 is there, so this root is equals to null, will not be executed. Okay. Now check, if the root of key, which is 100, is equals to the key, which is 100. Yes, in that case do what? Return true, and return true would be executed in this case. Okay, guys, I hope so that this is very much clear to all of you, absolutely clear to everyone. Okay, so when you are standing at the root and you want to find the root, it's just simple, it just goes in and finds it, equals, and then what happens? The execution stops. I hope so that this is very much clear to all of you. Okay. Next, let us say the value which you need to search for is not at root. Let us say the value which you need to search for is not at root. Let us say you want to search for maybe you want to search for key is, let us say, 30. Key is 30, root is 100, and imagine the tree is looking like this: 100, 50, and here it is 30. So on root left, the value is kept there. On the roots left and its left, the value is kept there. In that case, what you will do? This is root, this is value left, this is its left. You want to search for this 30. How would you search? To search, first the values are passed, 100 and 30. Okay. Key is 30 here, this is 30, root is 100, and you said that 30 sorry, 100 is equal to null pointer. No, this will not get executed. Okay. We have roots key. What is the roots key? Roots key is 30, which you want to search. And sorry, no. Roots key is what? 100. This is 100. Roots key. Root key is right now you are here, 100. Right now where are you? You are here. And you want to search for 100. So I want to search for 30. So what you need to do? You will say root key, which is 100, is equals to 30. No. Now check. Else if 30 is lesser than 100. Yes. 30 is now lesser than 100. So what will happen? The code will go right inside here, and my camera shut it down. Let me just go back. So it comes under here and return call the same function again, guys. Now this is very important. Why I am saying this is very important? Acha, let's remove all this. I want a proper drawing screen. Okay, let's do one thing. I'll take up a screenshot of this. Guys, I wanted to emphasize onto this more because I wanted to teach you something about it, that this is most important thing that you will come across. I hope so that this font size is way too clear for you to understand, right? So this is our code. This is our code. Okay, yep. So this is our code. Okay, now let us understand some few points here which is very important. Let's dry run this. So let's say this is the tree, 100. On the left hand side we have 50. On the right hand side we have 150. On the left hand side we have 30. On the right hand side we have 70. On the left hand side we have 120. On the right hand side we have 170. This is our binary search tree. For example, you take, this is our BST. And I want to, let us say, search this 30. So what is the root right now? The root is 100. The root is 100. The key value. So root is 100 and the key value is 30, which needs to be searched. We need to search this 30. You got my point? These are the two main criteria that we have. Okay. And now I said, call this function. What is the value of root? This is 100. What is the value of key? This is 30. Understood this? Check if root is equals to null. Is root 100 null? No. That means do not execute this. Do not execute this. You got my point? So I'm not clearing it, like I'm just saying that right now do not execute this. Guys, listen to what I'm going to say and also make sure that you are in sync with me. If you are not in sync with me, you will lose this recursion level. Okay, because we are going into deeper recursion. Okay, deeper recursion. As we go into deeper recursions, you need to be careful here. Okay, so here in this case, right now root value is 100 and root is not null because root is 100 right now. Root is there in 100. Come on, guys. Okay, my battery went off. Now let me just quickly remove my battery and replace the battery, guys. Just a moment. Yeah, we are back, guys. We are back. I hope so that you can see the battery is over. Now, yeah, we are back. I hope so that everything is clear. So battery got over, guys. I have replaced the battery and the new battery is now plugged in into the camera. Now we can see. I hope so that I am visible. Please, okay. Alright, guys, this is very important concept. Very important concept. Why? See, root was null or not. It was not null. Root was not null. When root was not null, do not return this. Come directly here. Now, is the root key equals to the key? Is 30 is equals to 100? No, this is not true. So don't do this. Come directly to this one, next one. Else if key which is 30 is lesser than 100, root key, yes, this case gets executed. So return what? Now this is a very important concept, guys. Return what? Right now we are here. Call this function again. Call this function again. Call this function again, and this time the new root value is set to roots left. That means now this becomes the new root. Now the root value has become 50. You got my point? Root value has become 50 and key is still 30. Okay. Root value has, now this is the new root. That was the old root, this is the new root. If the 30 is smaller than, the idea logic is, if this 30 is smaller than 100, then go towards its left and call the same function again, go into one more level of recursion, call the same function again, and the new root will become roots, current roots left, which is this one. Okay. David Wong, hi David Wong. Understood? So put the new root as this. Thank you so much, David Wong. Alright. Put the new root as this. And once the new root has been set to this, again call the same function. Recursively you have done. We have gone one more recursion level down. And then what happens? Check again. Is root, which is current root is 50. Is 50 equals to null? No, 50 is not equals to null. So do not execute this yet. Come directly here. Is the root key equals to key? That means it is asking if the root key, which is new root, is 50 and key value is 30. Is it the same? No, it is not the same. No, it is not the same. So do not do this. Now go here. No, it is not the same, right? No, it is not the same. So what do? You go here. And what is the key value? Key value is 30. So key value is 30. So there you go. Is this 30 smaller than the root key, which is 50 right now? Yes, this is true. And when this is true, call the same function again one more time. This is the second level deep recursion. Second level deep recursion we have gone. Understood this very clearly? Second level deep recursion we have gone. Now the new root becomes, root of left, means this was the root. Now this root is now updated to this 30. You got my point? And now 50 has become 30. Now the new root has become 30. Yes or no, guys? You understood this? If you have any doubts, please do let me know, guys. And the new root is 30. When the new root is 30, again this is called, so this changes to new root is 30, the key value is also 30. Is the root equals to null? No, do not execute this. Go here. Now is root key, which is currently 30, is equals to 30 itself the key? Yes. And if this is the case, return true. return true that the key is present, 30 is present. And there you go, ladies and gentlemen. And there you go, ladies and gentlemen. 3 levels down in the recursion we came and then we found it. The idea to this whole logic of search is start from the initial root to 100. Start from the initial root to 100. Okay, first the root was 100. Then you compared that value 30 with 100. You saw that it is smaller. So you call the same function again, but the new root is the roots left, which is 50. And now again 30 is compared with 50. Now it is even smaller. So what it will do? Now the root becomes the root left as the new root. And when this root becomes this, the root itself and the key itself is checked, and there you go, bam, you found the answer. And there you will say true. Yes, the node is present in the binary search tree. There you go, we have found. Now you saw one thing, you observed one thing, that here you found the whole thing in half of the time. That is the reason why this is your binary search algorithm basically in your trees concept. And this is why it is so efficient, that it can perform, sometimes it can perform in log n situation. Understand the point? Log n situation. Log n situation is happening here. This is, ladies and gentlemen, BST search function. Yesterday we have understood BST insert function. Today we have understood BST search function. I hope so that you have understood this really very much clearly. Got it? 47 views, average due time 1.39. Very good guys, thank you so much for staying with me throughout the topic. I hope so that I am able to teach you well and I am able to explain you the concept really well. Now this function is enough for today guys, because yesterday we did insert and this in today's class we did search function. But don't worry, in tomorrow's class actually we wanted 1 minute guys, 1 minute. Outside some because of the festival going on right here, and some noise disturbance is coming, but it's okay guys, we need to manage here somehow. Yeah, so that is the case. Okay, so what I'll do is I'll continue this class tomorrow, but if you have any doubts, we can start our doubt session right away and we can understand our doubts. If you have any doubts, please do let me know. I am here only seeing all your comment section right away. Seeing all your comment section right away. Yes, David Wong. Any doubts guys? Today we have done the search function. Why I am telling you that we will continue tomorrow is why there is one big reason for it, and that reason is that you see the code. Oh, let me just show you the code first. You see, in this case, in tomorrow's class, we want to do this delete function. Delete function is one of the, thank you so much David Wong. Thor Odin, thank you so much. Thank you so much guys. Keep on supporting us like this, and it motivates me to keep on creating content like this. And my camera is switched off. Let me just bring my camera back. Apologies for that, guys, because I am only again and again operating the camera on my own, and I'm trying to make this videos for you. When you show us this kind of love and support, I get motivated really to come online as soon as possible and teach content like this. All the videos that we have creating and we have recording our live sessions, all the recordings are kept in a playlist. If you have missed any content, you can go ahead and watch the content here. Keep on. What will be the class starts tomorrow? I don't know, David Wong, at what time is your time zone, but according to India time, Indian Standard Time IST, it is 7 o'clock in the evening. 7 o'clock evening IST, Indian Standard Time. 7 p.m. in the evening the class will start, and I will come and I will teach you. Tomorrow I will want to teach you this delete recursively function. Guys, very important function, and this is going to be one of the toughest function to understand. So if you have understood this function, then most of the part in BST binary search tree is over. This is one of the most toughest part to understand. Alright guys, I hope so that this is very much clear. Why I don't want to take this today is only 15 minutes are left according to the session to end, and it will take around say almost 1 hour time for us to understand this. You see, the problem with is what is the problem is, I'll show you what problem is. You see, when you have a binary tree like binary search tree like this, let's say I have 100 here, I have I have, let's say, 50 right over here, I have 150 right over here, and I have 30 right over here, I have 70 right over here, and I have 120 right over here, I have 120 right over here, I have 170 right over here. Okay, imagine this is the binary tree. And one more thing, let us say this is 110, this is 110, and yeah, okay, and this is gonna be 130. Let us say this is your binary tree. Imagine this. Okay, this is your binary tree, and you want to let us say delete this 120. The logic behind this 120, deleting 120 is simple, but it becomes complicated when you want to actually delete and deallocate the space. How? You want to delete this 120. First you want to do a search on it. First you want to search this 120. How to search? You know how to search. Just now we have done the search method. Okay. What you will do? Again apply the search which we have done today. This is the root. Key is 120. So what you will do? You will to delete. How to delete? Problem with the delete is that you cannot just delete an element like this. You cannot. Why? Because you see it has two children. You have a left child and you have a right child. If you delete this, then this whole subtree will be cut down. And when this subtree is going to cut down, it will distort the binary search tree functionality or rule. And for that reason, you cannot just delete it directly. So there can be two cases. Case 1, node with two child nodes or two children nodes, like on left and right. And case 2 can be node with 1 or 0 child node, either left or right. I hope so that you are getting my point, what I am trying to say. Two cases can be created. Either the node will be with the two child, in this case this node is with two children, left and right. So you cannot just delete it because you have to find its successor. And this is what we are going to discuss in tomorrow's session. This is one of the most difficult functions that people are not able to write, and students are almost confused in this. So let us focus on to this tomorrow's class, guys. I hope so that in today's session it was very nice, and I hope so that whatever I wanted to explain you have understood that. And yep, thank you so much for watching, guys. If you have any doubts, I am here for the next 10 minutes to clear all your doubts. If you have any doubts, please do let me know. I am able to see our chats. Everything is absolutely working fine over here, and I can see the chats. If you have any doubts, please ask me and I will share your doubts. Is graphs coming up in future? Yes, Thor Odin, the graph is coming up in the future. So see, right now we are doing binary search tree, right? After binary search tree gets over, we will do splay tree. I'll do splay tree, SPLAY, splay tree, AVL tree, red and black tree in DSA. Then once this tree gets over, we will do heaps, priority queues, okay, heap priority queue. Then we will do graphs. For graphs we will do all the graph algos, and we will do BFS in graphs, we will do DFS in graphs, we will do all the theory plus basic programming in graph. Then we will start advanced concept of graphs, where we will study about the graph algorithms, where we will understand about the starting one, Dijkstra's algorithm. People call it as Dijkstra's algorithm, right? We will call it as Dijkstra's algorithm. We will do Kruskal's algorithm. We will do Prim's algorithm for minimum spanning tree, okay. And we will be doing Bellman-Ford. We will be doing topological sort. We will be doing Khan's algorithm. This is just the graph content that we are going to do, and my target is to finish it as much as possible in this month. My target is that. This is just the content of graph which you see, guys, which will be coming up. Thank you, David Wong. BFS, DFS, theory, basic programming, graph algorithms like topological sort, Khan's algorithm, Dijkstra's, Kruskal's, Prim's for minimum spanning tree, and then Bellman-Ford. All of these are going to be taught in my live sessions. I'm soon gonna teach you in this. So we are following a proper syllabus, guys, and we are going to make you prepared for your placements. So if you are really interested, please stay tuned with us, keep on supporting us, and yeah, it motivates us to make such content for you guys, and we love it. So thank you guys so much. Alright, I will tune in tomorrow again. See you, David Wong. By the way, my name is also Ashank David. I am also David. So thank you so much, David Wong, and I will see you tomorrow. Wait a minute, guys, I'm not going anywhere. My camera is about to get, yeah, before my camera gets switched off, I just pressed the button and it came back. Alright, so yeah. So guys, that's all for today's class. I wanted to say bye bye because the time is over and there were no other doubts being asked here. So I thank you so much, guys, for watching today's live, and I'm also enjoying because people are coming like this, how crowd is coming, and we are able to engage people here and we are able to learn so many things here, guys. Thank you so much for watching. I am privileged to be here, and I am loving this part of teaching DSA live. Thank you so much for watching, guys. Tomorrow at the same time at 7 o'clock Indian Standard Time, I will be coming live, and there I will be teaching you how to delete a particular node from binary search tree, and I'll explain you each and everything in depth. Thank you guys so much. This is Ashang David again signing off. Please do share this stream as much as possible to those people who are in need to learn DSA and they don't have resources. I'll be providing each and everything related to nodes, programs and each and everything in our live sessions. And also don't forget to like, share and subscribe to our channel Coders Arcade also, so you don't miss any future updates, as well as don't forget to press the bell icon as well. Thank you so much, Vivek. Thank you so much. I hope so that this course will get viral and this more people are able to join us into this live stream and live session where I am able to teach DSA like this and keep on doing things like this. Because of your support, you guys are the founding pillars of this channel. Without your support, we could have not reached till over here. And thank you guys so much from my heart. I love teaching when people and interaction like this happens in my class. And yeah, thank you so much. And also don't forget that in future we are also trying our best to provide you internships. Now we have tried to make internships online also and offline also. So if you are interested in getting internship from Coders Arcade related to development or testing, please do let us know. Soon, it is not yet started, but we are going to soon start, very soon. As soon as it gets started, I'll definitely ping you up. And don't forget to follow us on Instagram and Telegram. Telegram is the main channel, guys, where we will be posting daily updates. We'll be posting all the notes and special sessions, whatever it is, information, we will be providing all of that into our Telegram channel. So please do follow us on Telegram also and join us in the Telegram community. We have just now created Telegram very soon, and very less people are there into Telegram, but please do join our Telegram also. Yes, Vivek, sure, we are starting to provide internships very soon. So I will be explaining you about internships on Telegram. So make sure that you are connected to our Telegram. Right now we have just created our Telegram, and you can see that it is only 52 subscribers that we have right now here. As you can see, if I can focus, wait, let me focus it onto clearly. You see, this is our Coders Arcade Telegram. Right here you can see the icon here, and we have just got 52 subscribers. So keep on following us here, guys, and all the things, everything I keep on posting right here. Okay, anything related to internships, the link for this Telegram channel is already provided into our description below. Go ahead and click onto the description and join us on our Telegram channel. Telegram is major, guys, because all the things you can discuss with us directly. You can contact me directly onto my Telegram, and I can help you regarding that. And guys, thank you again so much for watching this content. This is Ashang David. I will be signing off. Vivek, Wong, Odin, Ronnie Plays, thank you so much for joining our live session. And there are many more people actually who have joined our session. We are ASD, Ronnie Plays, Vivek, and a lot of people. So David Wong, thank you so much, guys, for watching our channel. Shout out to all these people here who are there into our channel, and I hope so that everything goes well. By the end of this month, I'll be finishing up the DSA part most probably, and will be able to cover up all these concepts as well. So guys, thank you so much for watching, and I'll see you guys tomorrow again at the same time. Till then, stay safe and keep on learning. Happy learning, guys. This is Ashang David signing off. I'll see you tomorrow. So yeah, that's all for this live session, guys. I'm ending this live, so there you go.